Hello everyone, my name is Aaron Mazzeo, and today we're going to be covering our first example on Ansys for solving the 2D heat equation. And as a reminder, last time we were working on a problem with a turkey, and we modeled the turkey as a two-dimensional square. And if we run the simulation from MATLAB, we'll run here. Oh, here we go. If we run this simulation, this is exactly the same script that you started with for the current assignment. It's called Hello Neumann 2D Start Turkey.m. But we see that after running for 4 hours, or that's a simulation set time, that's not how long it takes for the simulation to run, we get a certain temperature in the middle of the turkey. And in this case, the temperature is below what we would desire. We desire 165 degrees Fahrenheit for a nicely cooked turkey, and as we'll see in a couple minutes, this turkey comes out to be less than that. So in the assignment, right, the opportunity is to change the number of the length of the width of the square box, and that we do with the number of nodes. Not necessarily best practice all the time, but that's how it's set up. And you have the opportunity, we have the opportunity to change the heat transfer coefficient for convection. So we're going to model the same problem and see if we get the same result that we got, or same problem in Ansys, and see if we get the same result that we got using finite difference with MATLAB. So let's go ahead and proceed to Workbench. When you open up Ansys, this is what you should see. And we're going to do a transient thermal problem. So if I click here, I'm just left clicking and then I'm holding it and I'm creating a standalone system. And we don't have to necessarily do all these steps in the same order with Ansys, but it's not a bad idea to go from the top to the bottom. And if you double click on the engineering data, this gives us an opportunity to insert the material properties for our turkey. So default is structural steel. If you've done Ansys before, you've probably automatically accidentally not changed the material and just run with structural steel. Okay, it's happened to me, but we're going to try to avoid that mistake today. And we're going to enter turkey for our new custom material. And this is going to have a thermal conductivity. It's going to have a specific heat, and it's going to have a density, right? Because we know that thermal diffusivity is going to be the K, the thermal conductivity, divided by quantity density times the specific heat capacity, right? So we need those three parameters. Now, what are the values that we should put in? Well, we can look back to our MATLAB code where we had some values for the density of the turkey. So rho is equal to 1050, K is equal to 0.5, and C is equal to 3530. So let's go ahead and put those numbers in. Can I remember them? So density was 1050. The thermal conductivity was 0.5 watts per meter Kelvin. If you notice, right, this is per degree Celsius now, right? No difference for what we're doing. And the specific heat was 3530 joules per kilogram Kelvin, or joules per kilogram Celsius. Okay, so this is now in here, all right? And if you want to change colors or do anything kind of fancy like that, that's kind of fun. Yeah, we'll just go ahead and move back to the project here. So come over here, click on project, and we're going to start putting our geometry. I just did the thing I didn't want to do. I double click, and when you double click, it takes you into Ansys Discovery. You're welcome to use that if you like, but what I actually would like us to use instead is space claim. And so now we're in a little bit of a wait cycle. And while we're waiting for this to fix itself, we can come over to our simulation in MATLAB, and we see that we have a runtime, right? We ran the simulation for 4 hours, 14,400 seconds, and we have a mean temperature, and we have a middle, in the bottom temperature, okay, which is really the minimum temperature of the system. So as we're waiting for Ansys, okay, so this is a fancy interface that we're not going to use. So I close it, come over here, I'm going to right click instead of double click. All right, got a little trigger happy. Right click, yes, is Ansys slow? Hopefully the computer you're using is a little bit faster. But okay, let me try right clicking again. All right, come over here, right click. Now, here we go. Okay, new space claim to geometry. This is what we're going to do. But before I do this, let's avoid another pitfall. You're thinking, what is he talking about? Come over here, analysis type, we're going to do 2D. So 2D geometry, because it's a 2D problem. Now I right click, now I do space claim. All right, that was a lot of talking. All right, but while we're waiting for space claim to come up. All right, so what do we see here? We saw that the mid temp, okay, the last one, so if I do mid temp end, that will give me the last one, okay, minus 273, whoops, 273.15, because we're going to be operating in Celsius in Ansys. So we're looking at a final middle temperature of 35.4 degrees Celsius. This is way below 165 degrees Fahrenheit. Okay. So now, okay, here's space claim. It's up. You see something that looks similar to CAD. Okay, and it is CAD, right? It is computer-aided design, so it is CAD. One thing that is significantly different, though, between the way space claim works and the way that, say, SolidWorks or FreeCAD or Pro-E or Fusion is that it is not very good at keeping track of the history. So once you sketch something, it's there. You can edit it, you can like pull, you can adjust it, but you can't go back and adjust its primitives. So just be aware of that, okay? So I haven't touched anything yet, but we're going to. We're going to click on the Z dot here. Now we're looking at the XY plane, and then you click on this middle thing, or almost in the middle, to create a new sketch plane. And I can just click there, and now that's my sketch plane. I left click on rectangle, I click once on the middle, and then I can make a nice little square, and I can click it again. All right. Now, what are the dimensions that I need? It's actually much smaller right now than I want. If I go back, I look and I see that, oh, my dimensions, I had 38 nodes, okay, plus 1. All right, so that's 39. And then n minus 1 times dx, okay, the mesh size, that gives me the length. So I can just type in Lx here, and it tells me it's 0.19. So it's 0.19 meters, all right? That's 190 millimeters, okay? Because right now everything's set in millimeters. So I'm going to come up here and hit dimension, hit this bottom one, come down, and then if I double click on that, I can put in 190, and it makes it really big, and I can use my middle button to zoom in and out, and I hit control and the middle button, and it brings it out. I need to do more of that. Okay. And I can hit control, middle. Okay, great. So that looks pretty good. What we're going to do now is end the sketch editing. So then it pops me out to this, and we're going to come over here and click on the word groups, or select, yes, groups, sorry. Hit the groups. Right now nothing's there, and we're going to name the boundary conditions, the edges that we're interested in. Okay, so if I click once left, and then I do create name selection, okay, or name selections, or name selection. It's group 1. I'm going to call this left edge. All right, real original title. Come over here on the top, create name selection. This is going to be top edge. Again, very creative title. This is going to be right edge, enter, okay, and then I come to the bottom, left click, and then come over here, create name selection. When I see NS, I'm like, create namesake. Oh, that's, no, I'm not, I don't want to call it the Mazzeo edge. Okay, and so, oh, I didn't like that because I accidentally put in top. What I need to do is I need to put in, I'm going to rename, I'm going to call this bottom edge, just like that. Okay, so now we've got our edges named appropriately. Okay, and we're actually done here, and it's a little nerve-wracking because you're like, wait, I just created this thing. Do I need to save it? What do I do? You just go over here and you hit the X, and it's done. Okay, and then we come back over to the workbench, okay, and we're going to double-click on model. Okay, that's the next step. So we just, you see check marks in the engineering data and geometry. Now we're going to do the modeling part. Okay, so at this point, we're waiting once again for Ansys, okay, to bring up this mechanical modeling software, and it's going to take it a couple of seconds to bring in our geometry, and we're then going to proceed to mesh this geometry, and then be able to apply the boundary conditions, and then be able to run the simulation. Okay, so one thing that's maybe a little bit counterintuitive, and I've messed this up before, you left click on this geometry, or you click on geometry, either way, and then you click on the surface, okay, the geometry, whatever it is, and it's fine. It says it has a thickness of 1 meter. That's fine. So it's essentially, if you look at it, all right, it is looking down at Z, but if you rotate it, whoops. Oh, which way? Which way? Whoops, I'm going the wrong way. Okay, sorry. Yeah. This is always confusing, right? And I do like a rotate. Okay. Right now it is a plane. Okay, but when it runs simulations, it actually thinks of it as being like 1 meter thick. All right, and remember that our boundary conditions are in watts per meter squared, and it's essentially thinking it's, it's completely insulative in these other directions, and boundary conditions essentially being applied infinitely in these directions, right? Unlike a airplane traffic controller. Okay, so once again, if you want, you can click on the Z, and then it just pops it like that. But the important thing that I want to make sure that we do, that I've made a mistake on, is that we assign the material correctly. So right now it's on structural steel, even though we put in the turkey. So now you put in turkey, you click on turkey, and there, now it will use the turkey model. Okay, you do that under you do that under geometry. All right, that's where we were. Okay, and it has 2 materials there, but that's the one. Now let's go over to mesh. And if we go back to MATLAB, you're like, why are we going back to MATLAB all the time? Well, because we defined a mesh, and we can go ahead and use the same mesh size. So dx, we're going to say is equal to 0.005 meters, okay, or 5 millimeters. So we come over here, and the element size, all right, right now it says it's got some default thing of 2.375 e to the minus 2, but we're going to go ahead and put in 0.005, whatever, however you like it, and hit enter. Now, one cool thing about, we're not going to do this right now, but one cool thing about Ansys is that if you click this box right here, it creates a P, and it actually creates a parameter, okay, that you can bring out to the top level workbench and run different simulations. So, for example, if hypothetically, right, you had to figure out if your mesh size was of sufficient size that you had convergence, you could bring this parameter out and test that. So we're going to unclick it for now, all right? And we've got our mesh. We've got our mesh size. We come over here, and now we can click generate, or you can right click, and do generate mesh. A lot of these things can be done on the tree on the left, or they can be done up here. So I don't know, we've been using the tree so far, so let's just do it up here on the ribbon. So I click generate mesh, and it's thinking, and hopefully that's about right. Okay, that should be our mesh. And now let's go ahead and apply some boundary conditions. So for that, you right click on the thermal and you hit insert and wait, what are we? Yeah. And we hit convection. Yes, like that. Okay. Or you hit on the transient thermal and you come up to the top and you hit convection. Either way. And then it pops this up. Now, the coefficient of heat transfer that we're using is going to be the 10 watts per meter squared Kelvin. Okay, that's this line right here. And the free stream velocity, or the oven temperature, okay, of the air is going to be 436 Kelvin. That comes out to be 325 degrees Fahrenheit. Okay, and that's typical temperature for cooking a turkey. So we're going to put in the 10. And we're going to, so 436 though, so I need that in Celsius. So I'll just come over here, 436 minus 273.15, so 162.85. So we're going to come over here and we're going to put in, I can't even remember, I just forgot the number, 162.85. All right, so 162.85. Where's that? Free stream? Yes, 162.85. 162.85. Okay, so now that's in. But we haven't selected where this is applied. Well, remember we named those selections, so we can go to name selection, and we can then come down here, and let's just do left edge, because that's the top one. All right, and so now we see that the left edge has been selected or highlighted for us to do this convection. Now, we could have maybe done a name selection or a group with all the edges at the same time, but we didn't. So what we're going to do here is we're going to duplicate this, and then when we come down, we're going to move to the top edge, and we do right click, duplicate, and we're going to do the right edge. We do right click, duplicate, and then we can do the bottom edge. Voila. All right, so now our boundary conditions are set. Something that, again, the order, I could have done this in a slightly different order, but if I click on the initial temperature, okay, that's kind of important. I said that the chicken was maybe slightly thawed, okay, uniformly. And when we did the problem back here, it was 283, okay. So that comes up at 283 minus 273, that's 9.85, right? 9.85. Okay, so we're going to come over here and we're going to do the initial temperature, and we're going to say it's going to be 9.85 degrees Celsius, just like that. Okay, and at this point we could run the simulation, but I'm going to go ahead and create kind of some images, some solution images before it runs. So if I click on solution, I have the option to right click and insert a thermal temperature, or once again I can come up here and do thermal temperature, either one. And let's just look at, we just want to see what the temperature of the whole system, the plots, right? So we're just going to do geometry selection, and it's going to be all bodies, and it's applied. All right, so this is going to do all bodies, and it's going to show us the temperature profile on this body. And now, okay, it's kind of fun. We've got, or it didn't show up yet, but it's going to, okay, it's going to project eventually. But now it's just, it's set up to give us the temperatures once we run the solution, once we solve. Okay, and the other thing that we can insert is maybe a little bit more complicated. All right, but it's going to be the middle temperature. So what we're going to do actually is we're going to come back and click on the mesh. And there's a cool little thing you can do here where you click on, so these are kind of more standard vertex, edge, face, body, but next to it there's something called node, and then element face, and element. We're going to click on node. Okay, so we want the node temperature, hit that, and we're going to try to find the middle node. So how do we do that? We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, okay? And we're gonna try, I think that's about, let's see, maybe one more up, okay? And no, about there, okay? I think that's the middle, all right? And I probably should have done a better job, okay, at this, and there are other ways to do it, but we're gonna select the node, okay, for this example. So that now is going to be something that we right click. Sorry, we right click on it, and we're going to create another name selection. All right, and this is going to be the middle node. And just like that, we hit OK. Once we've done that, we come over to our solution information, solution. Okay, and we're going to do thermal. We're going to do temperature. And this time, we're going to do a name selection, and we're going to select our middle node, right? We can also do like top left edge and top edge. We can do these different profiles, and they're kind of fun to look at too. But we're going to say that's in the middle. Okay. I think we're ready. Oh, and we can rename this if we want. So we can rename this to be the middle node. Okay, temperature. So let's go ahead, we click on solution, and you can right click and do solve, or you can come up to the top and do solve. Oh, but we probably should change the time for which we're running. So let's go analysis settings. Right now it's only set to run for 1 second. So let's change that to 14,000. And you look at, there's initial time set, max, minimum, max, all these different parameters. It's program controlled as well. You can change different settings. But right now we're going to put in 14,400, and we're going to watch that the initial time step, the minimum time step, and the maximum time step, the computer changes them. Okay, and so, we're going to essentially get a table of the values at these time steps. And we could change that if we want, but this is what we're going to have right now. Okay, I think we're ready to go. So let's now go to solve. It doesn't take very long. All right, we see it's building, solving, and there it is. Okay. Now, what is there? Okay, you see, like, there's the profile, there's time, like, that's not really that interesting. Well, let's click on temperature. Voila! All right, look at this. Okay, so this shows us the profile. It looks kind of familiar. And like I was saying, like, it extrudes it. Once you run a thing, it, like, extrudes it into a block. Not super useful, but kind of fun. Then if I click on the Z again, it takes us there. All right, so we kind of have information already here, okay, that's useful, because we know the middle, all right, is going to be the minimum, right, temperature. So it's telling us that it gets to, at the end, or we can look over here on this grid, okay, at the end, at 14,400 seconds, the minimum temperature is 37.008. Okay, and what do we say here? That our mid temperature, okay, at the end, mid temperature minus 273.15, 35.4 versus 37.008. So they're pretty close, all right? They're maybe not exactly the same, okay? And remember, we're doing finite element versus finite difference, but they're pretty close, okay? And if we change the settings a little bit, we might get slightly different results. So if I click on the middle node now, okay, now you see the minimum, maximum, average. There's only one temperature, right, at this middle node. Okay, they're all the same, but and like we saw, it's the minimum. It's 37.008. So we're pretty confident that yes, my kind of a little bit by eye calculation where the middle was is in fact giving us the minimum. Now, what you want to do for your deliverables, okay? So I would like you to go ahead, all right, and take a screenshot of this, right, however you like, and put that into a PDF. In addition, I want us to do a nice little comparison, all right, between our Ansys model and our MATLAB model. And probably the easiest way to do that is to come over here and do a couple copy and pastes into MATLAB. You're like, oh, not MATLAB. Yes, MATLAB, because it's so awesome. Okay, so you click. So we want to do the middle node, okay? And I'm going to click over here, and I'm going to click on time, and I'm going to do copy cell. and then I'm going to come over to MATLAB, and this is the same script that you have, okay, the turkey start middle, okay, and let's just do Ansys time, okay, and then I make a bracket, and then I hit Control V, okay, and that gives me time, and I just do a semicolon, all right, and then I'll make another one called Ansys mid temp, okay, just like that. And then I'm going to come over to the modeler and or mechanical model, and either any of them, they're all the same. So I don't know which one do I want. I'll click on this one and I'll do copy cell. All right, like that. And then I'm going to bring it in, and I have it like that. And I can do, since I've been working in Kelvin, I guess I'll just do it in Kelvin. All right, so I add the 273.15. All right, and that's going to add it to every one of these elements. Okay, now I already have some figures that are useful. I'm doing a comparison with the mid temperature. Okay, so it's probably not bad. I'll just copy this right here, and it's plotting, the MATLAB stuff. Now I'll have it plot the Ansys. So we said it was Ansys time, and we're going to have Ansys mid temperature, and I'll give it a different symbol. Or is that the same symbol? Yeah, it's a different. So now we have asterisks, right? Time, middle temperature, final temperature. This is from MATLAB. Okay, so we can maybe say this is the MATLAB final temperature. Okay, the H is cool. The side length is cool. All right. Let's maybe add a little bit more information though. So now I'm going to do, well, let's see, where should I do it? I'm going to do, yeah, I'll just do it. Fine, I don't mind doing it here. I'll do the Ansys final mid temperature was, we're going to do num, so I got to do this, comma num2 string, and this is going to be the final Ansys mid temp, and I'm going to do end, so that'll give me the last one, and I'll do a comma, and then I'll do that, and then I'll do K. All right, so that will give us the final mid temperature for Ansys as well. I think we're good. Now, I could run the whole simulation again, but I don't want to do that because I did that at the beginning of this session. So I'm just going to copy this, and I can either do evaluate selection, okay? So evaluate selection like this, or I could just copy it down there, and it did it for me. So evaluate the selection. Oh, Ansys time. It didn't like that. Oh, that's because I didn't run this. So I got to copy all this, right? It doesn't know about that yet. Okay, so now right-click, evaluate selection in command window. Okay, so this is good. It's showing us a comparison, all right, and it's also throwing up an error. Okay, why is it throwing up an error? Because I did a boo-boo here, right? So I need to close this parenthesis. Okay, are my parentheses all good? Let's try it now. Okay, and now the data are actually in Ansys, in MATLAB, so I'll just run this last part. I don't need to do that whole thing again, so evaluate. What's it? Invalid expression when calling function or indexing variable. That's the disadvantage of when you do this, because now I don't know which line number it's in. But figure 6, so I have this, it has to be my this line of code where I just added stuff. Okay, so this is there. Once again, it's embarrassing when I can't get my stuff to work as well as I like. But I think that's probably what it was. The parenthesis was in the wrong spot. Okay, there, it added it. Okay, so what do we see? We see that, oh, and maybe I should add a legend because we don't know which one is which. I mean, although we do know which one is which, the MATLAB code was under-predicting slightly what the Ansys was. So let's just do this. We'll add a legend. And the first one was MATLAB, and the second one was Ansys. Okay, and I could just write that, copy that in. Okay, and where is it? Yeah, this is the figure that you want to include in your PDF. Okay, well, I hope you found this example interesting, and we'll have much more time in Ansys for the rest of the semester, but this is our first example, and it gives us an opportunity to compare the finite difference method and at least this kind of black box finite element code that Ansys is running. And of course, if we change the parameters, we're going to see the resulting values change. Just like if we change the parameters in MATLAB, we're going to see those resulting values change. Thank you very much, and I'll see you soon.